Welcome. On this channel, I do unscripted, unedited videos about Linux programming and stuff. Recently, I have committed to a little online game project that is more about me learning things than it is about actually delivering a game. It is what we'll be continuing with today. Where I'm at right now is I've basically just prepared the project to work on. So I created a Git repository and did the makefile and kind of am ready to go. So let's pick this up here. So the information about the repo and stuff will be in the video notes. There is not much here at the moment. If we run this, it just says simply is a hello world, more or less. And the other thing I have here, this is ignored in the repo, so it won't appear in GitHub. But I have this folder. I have the original README from couple videos back where I was kind of discussing the possibilities about how I was going to do this. The primary thing I'm trying to sort out right now is how I'm going to make the deployment process work. The project has a significant constraint that I'm putting on it, which is that it must run on a single server. And the thing that I would like to kind of address early on here is, well, what does it look like to do a deployment? I'd like to have it as low impact, zero impact if possible. And I laid out a process that I intend to kind of experiment with over these next couple of videos. What I'm gonna have to do is I'm gonna have to write some code that I haven't written, and instead of doing it at the same time as the logic of the process here, what I'm going to do is I'm going to break those out into individual little pieces. So I am just going to write an echo server that simply listens on a port, accepts a message and sends it back, separate from all the other stuff. I am going to look. Some of these may not warrant whole little experiments all by themselves, but look at the code that I need to send signals, look at the code that I need to, and nothing complicated here, but open and follow the file, and whatever other things that I need to do. Do those all individually, and then once I've done those things individually, I'm going to go back and actually try to put together the logic to do the little experiment. Okay, so the first thing I want to work on is just a really dumb TCP echo server. I don't actually know this. Does what's it called? The sockets layer in the browser. Is it just WebSockets browser support? Yeah, it is just WebSockets, right? Okay. Does WebSockets support UDP? That was the question I actually had. What are the differences between UDP and WebSockets? HTTP is blah, 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 blah. I know UDP is a... I get the impression that it doesn't just by reading that. Real-time WebSocket and UDP stand out as two pivotal technologies. Protocol, full duplex, over a single TCP. So that is over TCP. On the other hand, UDP is simpler. Blah, 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 blah. Key differences, use cases. So now I have a question. I'm getting sidetracked, but does WASM networking support UDP? WebAssembly simply only supports. Now this is 1 year ago, so it's not that old. I have one of the important things the app does is communicate by sending blah blah blah. Is UDP socket just stubbed to WebAssembly libc port and is I found how UDP sockets are implemented at WebAssembly. Actually, they're emulated by WebSockets. It probably would work if both client and server were WebAssemblies. But my server is built natively, as Web doesn't support dynamic linking. All the code is bundled in one JS file. It sounds like that UDP, if it works, is not a straightforward thing. Now, HTTP3, I believe, since WAS API lacks support for network sockets, it's necessary to create the UDP socket using WASI's socket extension. Okay, so that makes it look like there is something. Ideally, the way I'm thinking of the client for this game is that it will just be, you know, probably a Rust application written to compiled to WASM and hosted on a site, making it as easy as possible for people to interact with the game. They just have to hit the website and they're in. The back end, of course, is this C program that I am working on now. The reason I was looking at this is I was trying to get an idea about whether or not we'd be able to use UDP. I think long term, that is my goal, is to do it as UDP. The game is fairly stateless. We can survive and handle, you know, packet loss at the, well, maybe not. Depends on my message sizes, I guess. I'm entertaining the idea of doing it via UDP, and I was just curious what the impact was there, whether I could care about it right now. I don't. What I do need to do for this video is I do want to do just a minimal kind of like, well, just a minimal echo hello server type thing, and so so let's just ask the internet. C programming, TCP echo server example. I mean, I'm almost guaranteed to find somebody had done exactly what I'm going to do here. So I'm just walking through this. Why do we have two? So we have server C. Oh, we have a server and a client. Line 57 and client. It's terminating. Terminator. Okay. So that's a good start. It doesn't give any mention of what the target was. I'm sure this will probably compile just fine. I don't see anything in there that stands out that says, hey, this is Windows or anything like that. So what I'm going to do is slight refinement. So I'm just looking, syssocket, systype, function design, chat between client and server. So we have a func. So then we have, this is the server, that is the client. Okay, we have an example. We just need to work our way through it and then understand the pieces as we do it. First thing is, so we're, do I want to do the server first or the client? Let's do the server first. I can use like Netcat or SoCal or something to hit it. So we're defining what port that we're going to be listening on. How do I want to do this? Oops, hit the caps locks again. Actually, let's... okay, so that's not going to compile because server port, well, it will. Is server port really just supposed to be an int? I mean, that will compile. Unused variable, but yeah, other than that. Now, okay, so we have a struct for socket address named server address. Mostly you're just going to watch me walk through this very slowly and tediously so that I understand the pieces. Okay. Stock address is not defined, so it's going to tell us isn't known, and I'd like to find where it's defined. I want to include these things one piece at a time so I get some sense of so let's start with, I guess that is one way to do it too, right? It's included in syssocket.h. So let's jump out. The storage size of server address isn't known. Wonder why. It should be defined, at least according to the man page, it should be defined in syssocket.h. So, in fact, right, it's still saying, hey, the storage size of server address isn't known, but yet I can do a size of server address. So let's try and fix this before we move on. So let's get that message. Well, you know, it's kind of dumb, but I'm going to try the exact message. And what do you know? Because it's a common enough thing, right? None of the other answers work for me. After taking a look inside syssocket, I didn't even see a definition for that. That worked for me. Include one of the following when using the correspond. If you're using... What worked was to include one of the following. If you're using in, that is defined in... these are defined in ns, and for whatever reason that name doesn't match up. Does something else eventually include that? That's something I'll have to keep an eye on. So I do believe oops, that did not solve our problem. Well, here, let's do kind of a more obvious thing, which is, let me just grab all of these, and does that error go away? So what do we have in this file? We have here, let me grab all of those. Come over here. What is this one? It seems like I should know it. Header definite miscellaneous symbols and types declares. Yeah. A bunch of that stuff. Yep. So, what is sysstat? Header definition, fstat, lstat, o. I think I had that in my list from my previous program, and I don't need it. Syssocket net. There might be a logical order to include those, but I don't know it. And they are just headers, so I shouldn't have any issues there. Okay, so that did get rid of it. And it has to be one of these. This is a duplicate. So it must be this one. Nope. Okay, if I have... that one gets rid of it. They must include each other, right? One of them includes the other or something. That one gets rid of it. But if I don't have either of them, right? Yeah. Okay. So, a little bit of info there. I want to kind of fix the order here. So, I know that I want standard IO, standard lib, error no, standard bool, standard int. Kind of a more logical order, at least in my head. Yeah, we'll leave it. Okay. Not needed. So the declaration on space captaincy 1-1, including string, blah, blah, warning. Oh, memset. Okay. Okay. That's cleaned up a little bit. That's all we need for that. So working our way through this. We have set a variable with the server's port. We have created our socket variable. We've cleared it out. Is that even necessary? Won't that our struct C our uninitialized zeroed. Our uninitialized struct member is always set to 0. It's a guarantee to be 0 if it's partially initialized, just like an array initialized. If it's initialized, it'll be unknown. Wow. That's kind of an odd thing, right? So like if I partially initialize it, it ends up 0. I wonder if I don't think I'm going to find the answer to this easily. I'm wondering if I were to do that, if it guarantees it to be zeroed, and I don't think I'll find the answer easy. That doesn't seem like a easy thing to ask the internet. I do think that will make it 0. And clearly the internet doesn't agree with that person. I do think, though, that I have a strong feeling. Okay. What is it doing? Cap box is off. I dislike that. Okay, I'm gonna switch keyboards. This is getting crazy. So I have a really super strong suspicion that that does 0 it, and then that would make this pointless. But I am going to go the safer route of just trusting what they have done and accepting that zeroing it is the way to do it. And then what they do is they say, hey, we're going to set this particular value in server address. Right, so I just want to read what the internet says about it. I don't want to look at presentation. I don't want to see it. I actually just want to look up sin family. Let's do that. Why does a sin family member exist? Blah, blah, blah. Okay, so it's always this. The reason for this is that it's possible to tell the actual type of generalized socket descriptor. Struct socket, blah, 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 members depending on the network protocol. And then sin family, SA family is sin family, sin6 family. So there are other types, and it just has to always be set. Okay. Okay, so we set the value. Host to network short. Host to network short. Transforms the value into host byte ordering format to a short value in the network byte ordering format. And I'm probably... I wonder if the little endian is... let's ask the internet. I think that... it's defined as big endian. So isn't that kind of ironic? Because isn't Intel is little endian, right? x86 use little endian, and so does ARM by default, at least in most cases, as far as I know. I know that they're the same in most cases. It's kind of ironic. I mean, that the network byte order is like the opposite of what the machine. The networking was invented on probably those, on old machines that did have big endian order. They didn't survive, but the network protocol that was created on them did. And then you have the Intel machines that ended up being dominant, that set little endian as the byte ordering that most machines are using. Even though I'm fairly positive a lot of ARM stuff can work either way, but chooses to be big endian. Okay, interesting. And I missed. Okay, so we set that. We need to set the port, and that has to be done in. So I bet we see this more where we're setting values and we have to call htons on it so that we are in network order. So again, what was htons was host to network short. Host to network short. I wonder if there's a host to network long. Oh, there is, right on the very next line. Host to network long is what we're using to set the address. Makes sense. So here we are setting SYN address to S address. Did I miss something? So that is our first mention of S address. So server address is what we zeroed out. We only set the SYN family. Then we come down here and we set the SYN port. And we're setting the address value to any. That's what we're doing. So we're setting the value to any value. Let's is used when we don't want to bind a socket to a specific IP. So so we're saying, hey, bind to all the hosts cards. So that makes sense. And then after that, we create a TCP socket. Creation returns -1 on failure. Okay, so we're going to, the socket itself is going to be just an int. And we're saying, hey, we want a socket, pfinet, I'll look it up, sock stream, I'll look it up, and we get our listening socket. Could not create, return with an error. Sounds good. Why did it do that? I don't even. Okay. Actually, I gotta fix that. There should be a. I can. So ADB. So I. Oh, I had B to all. Well, that just got fixed. Oops. Is it? Oops. There we go. Okay, so I should be able to build that, assuming that there's a build target. There's not. That's why I took it out. There is an all target. I'll just use that for now. Fix that later. Those are just essentially just quick shortcut keyboard bindings for myself. I want to go back to the Space Captain file. Okay, so here we were trying to create the socket. And, you know, obviously this is just a little bit of learning for me walking through each of the steps. So pretty boring for everyone else. Let's dissect this one next. Oh, actually, let me do this. Oh, I thought I had a function for converting those tabs. I'm assuming that's what we're getting as tabs. It might not be tabs. It might be some other random invisible character. Vim convert tab to space. To easily change tab, and then you use instead when. Okay, to easily change a tab-based indent to use spaces instead when no expand tab is set. You can temporarily set expand tab and use retab with. Should just be retab, right? There we go, it is just retab. Okay, I wanted to go through these constants. So PF, INET, and SockStream. AF INET and PF INET. What is the difference? You'll see mentioned mystical PF INET. This is a weird ethereal beast that is rarely seen in nature, but I might as well clarify a bit. Once, a long time ago, it was thought that maybe a address family, what the AF in the address family in INET stands for, might support several protocols that were referenced by their protocol family. What the PF in PF INET stands for, protocol family, address family. That didn't happen. Oh well. So the correct thing to do is to use AF in your struct and PF in your call to struct. But practically speaking, you can use AF INET everywhere. And since that's what Richard Stevens does in his book, that's what I'll do. I think they're actually saying just use AFNet and never use PFNet here. So up here, we use AFNet, and down here we're using PFNet, and that seems wonky. I think the book says use AFNet. Okay, constant SockStream. This is probably the choice between UDP and we'll find sockets. What is SockStream? Diagram and SockStream, right? So this is UDP versus Dgram is DDP and TCP. Okay, that's what I expected there. So we're saying, so this is about the I think that this first one is about the protocol. Well, it is protocol family. So we're in the, probably saying we're in the TCP family or something. I don't know. Okay, bind it to listen to the incoming connections on the created server address. This will return -1 on error. So bind, so we created listen socket here. We are binding listen socket to this, whatever's returned from server address. We pass the size of server address, right? That is odd. Oh, and then we're just simply saying if all of that was greater than 0, is less than 0, could not bind, and we exit with failure. Okay. Build. Oops. Build. Why does that not work? Because I was hitting the wrong key, because I can't get used to this keyboard. Okay, so we create what we need for a listening socket. We actually bind that to the server address. The server address is any acceptable address and port. Well, it's a specific port on any one of those available network interfaces. Okay. Int, wait size 16, maximum number of waiting clients, after which dropping begins. Oh, that isn't interesting. And that is used in the listen command and the listen function call. Listen, wait size. I want to look that up. I want to see what it says about how many. I already got that wrong. I should just, it's wait size. How to make, I'm curious what are practical limits on that value. And what recommendations are for it. Wait size recommended. Do they use a different name for it? Okay, so I'm gonna find that later, but I'm very, very curious about what the recommended values are for that, and and the performance issues around having the number being large or small. But what we do is we simply listen. We're going to listen, and if it doesn't work, we bail. Everything compiles cleanly. Nothing unusual going on there. Okay, socket address used to store the client address. Interesting. Is there anything here? So we have struct sock address in. And then we have int client address length. Unused variable. Okay, yeah, that makes sense. We did not use it. So we have a forever loop here. in that loop, we are going to open a new socket to transmit data per connection. So we define a variable for the socket. Oh, let's copy it and then dissect it. So we define a variable for the socket. We accept from the listening socket. We're passing a struct, which is a sock address, which is going to be our client address that we created here. We pass the client address length, which is currently 0. We pass the address of this length, obviously, so it can set it. If all of that is less than 0, we fail. Bail. Now, let's go back and look. Yeah, it's just using return, but... Oops. Warning, pointer targets and passing, blah, 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 except differ in signedness. So client address length is an int pointer. So, interesting. So it can never be, okay. It's never gonna store any kind of metadata in it. It's just, it is literally just the length. Okay, so we have a bunch of variables to find. Let's take a look. Okay, so that's why retab is a little funny to type. It's all on one hand. It's all on the left hand. I just realized. Okay, so we're defining an int n. We're defining a length 0. We're defining a max length 0. Why break any of those up? Well, okay, so I bet you the reason that they were like that is just because logically length and max length went together and is slightly less related. So we have a character buffer that is max length. It's only 100 characters. We ended up with a pointer to that same buffer. Not sure why we do that. Printf client connected with IP address, blah, blah, blah. So we're just getting a little output, debug output here. Client connected with that address. INET no into a client address. Okay, so what is this? I'm guessing it's going to change some numeric into some string. In which case I have to ask the question. I want to go back here. I want to go here. So all of those converts the internet host address from an IP4 into a binary form in network byte order. Returns a non-zero. Right, so this is each of the 4 numeric parts specified by a byte in the address. The bytes are assigned left or right. The parts, blah, blah, blah. Okay, so that is just the conversion in network ordering. Okay, so we get somebody that connects. So we keep doing crap so we're going to end up with let's do this. So we're going to have another loop. The client connected. We start another loop. This loop is going to keep on running, according to this, as long as the client keeps the connection open. So what we're doing is we're receiving n bytes probably off of the socket into the buffer that is of that length, as long as what we receive is greater than 0. So presumably receive socket ends with a negative value, I'm guessing. In fact, let's do it this way. Receive messages, calls are used to receive is the only difference is the presence of flags. If no messages are available at the socket, the receiver calls wait for a message to arrive unless the socket is non-blocking, in which case the value is -1 returned, and error no is set. The receiving calls normally return any data available up to the requested amount rather than waiting for receipt of the full amount requested. Okay, good to know. Now what we do here is a little housekeeping, so this is all pretty straightforward, so I'm just going to grab it all at once here. Assuming I can drive my mouse. Okay. Okay, what do we do here? We are increasing the buffer pointer. Oh, maybe this explains why, because to the length received, we're subtracting the max length of the next receipt, reducing down. We're setting the length to be what we received, and here we're actually printing out from the buffer. Interestingly, I don't see us setting, does it, I can't imagine that receive it has a 0 terminated buffer, and I don't see us terminating the buffer. So I think they're basically relying on the fact that the client is sending the null character, null terminated strings. Interesting. Interesting. Okay. Now what we do is we echo the received content back to the client. And then we are going to close the socket after. So at this point, it's closed the connection. We close the connection. We close the listening socket. And then we exit, right? So there's our program. Build that. Implicit declaration did you mean p close? So let's take a look. No, I did not mean p close. So listen sock. So it built and it had, so let's clean and build again. So we're probably missing let's take, I want to get this, and let's go over and ask Chrome. So that I think these are related questions. And oh, well, let's start with one of the things that I did change. Let's just make sure all of those are included. And make sure that having all of those included doesn't okay, so what was I missing? I have ARPANET, net syssocket. It has to be, right? Yeah. So required. There we go. Clean build. Okay. So right now we should have we should have been space captain. Okay. Source main. So I want to put a little bit of, oops, I don't want main. Source space captain. I want to put a little bit of debug info in here. So yeah. So we are running. I'm not going to do that. Do we have our printf down here? Or no, we have a printf about received. So if I what are we doing? We're running on 8877. So if I come over here and split this one, so if I space captain. So space captain is running, and shit, been so long. I need a netcat how-to. Is it just go. So let me netcat. So I should be able to netcat localhost the port, but okay, so can I do it this way? Can I netcat? Okay, so it's there. So can I netcat localhost? Oops, let me do it this way. Pipe that into netcat localhost port 8877. So client connected, received. Okay, so interestingly, I'm not quite following the logic over here. why? Oh, I bet you I get it. This is setting up that terminating value. So let's look at receive and receive v. So that's a flags value. What does flags do? The only difference between receive with a 0 flags argument is generally equivalent to re2, but blah blah blah. Is equivalent to sock fd blah blah flags null. All 3 calls return the length of the message on a successful completion. If a message is too long, excess bytes may be discarded. If no messages, I don't quite get why, if the caller is not interested. Okay, so this is the way we're seeing it. I'm not quite sure how we're getting the null terminated string, right? So I'll have to investigate that a little bit better, because we're just printing out the string. So if I come over here, and oh, if I do this without anything, right, it just keeps it open and I can type at it. So it keeps appending it to the buffer while it's reading right now. That's what's going on. Foo bar baz. Okay. Okay, so we achieved the basics. I have a little bit to figure out, which is I don't quite follow receive and how we're ending up with how is it that printf is outputting only the length of the buffer. Presumably it's formatting a string, so that string is saying, hey, it's null terminated, but why is it null terminated? I don't believe netcat is sending it null terminated. I think that something about the code is adding it, and it probably is that 0 flag, and I just don't quite get the details. But I'm going to consider this good enough for now. You know, I've been using Ghosty for a while, and I think that's the first time I've ever used panes in it, or dividers, or whatever it calls them. So what we're going to do here is, okay, I haven't committed anything, and what I want to do is I want to tag, I want to start tagging these with each of the video numbers. And so this video is 25. The previous was, I'm going to have to look that up real quick. So let me do it this way. So this video is 26. I wonder if I had the title card set right. And what I want to do then is I want to tag the previous video. So I want to tag -a. Before making any commits, I want to tag -a. How am I going to name these? We're going to do this. So 0025. And does that work? Oh, get tag -a video 0025. Yeah, it wants a message if I just do a -a. Video 00. I don't know. Okay. What I want to do now is let's take a look at source main. This will be for, I'm going to commit video 26 and tag it. Oops. Is there anything here I want to clean up? Not particularly. When I come back in the next video, what I'll end up doing is probably just commenting this out and setting it aside as I work through some of the other pieces. The other pieces aren't very big. Well, I need to write the client. Oh, how do I want to do the client? Do I want to have the client and the server in the same repo? Probably. So I'll figure that out. So what'll happen is we'll probably end up with a server client subfolder in this repo, and otherwise I'll preserve the structure we have here. So actually, let's just do that now. So let's lslha. Let's make a directory called server. Let's move, let's make clean so we don't have extra stuff. Let's move the makefile, the readme, and the source directory into server. Get status, that will work. Now let's add server. Let's let's copy. I need to fix up the git ignore now because it assumed it was at the root. In fact, I'll just do it this way. I'll make it smarter later. Oops. These ignores were originally written assuming they were at the root of the repo. I only have, I just made sure that they apply to what's in the server folder. I want to see something. Miscellaneous should not be getting added. Oh, guess it should be until I fix that. So, modify git ignore. I renamed the readme. It fell down into server, fell down into server, fell down into server. The space captain C is a new file, and why is that a new file? Oh, I wonder. Oh, because it both changed and moved. Okay. Git status, git commit. Do simple. Git push GitHub main and git tag 00 video 0026 video. I might start writing better messages in these tags in the future, but it's completely duplicative of the commits most of the time because I kind of am going to end up with one tag, one commit. Not always, but in fact, maybe I should get away from that habit. Git push. Oh, all done. Yeah, git push GitHub main. Okay. That is all for this video. I'm sure it was exciting for the viewers to watch me stumble my way through a bog standard. This is how to make a sockets connection. We clearly are going to have to do things that are a lot more complicated in the future because it's going to be. I'm assuming that it will be many threads running. listeners, we'll have to figure out how that works. I don't quite understand it. So until the next video, thank you.